on 10. On 10 it said your sum of the angles was, 1800. See, I hit the wrong one there. If the sum of the angles is 1800, you got to figure out the number of sides. What we do here is take this, we set it equal to n minus 2 times 180 equals 1800.
Oh, correct.
Okay?
Okay, didn't do it right. Never mind.
When you do that, it tells you, I'll walk you through it here. When you set that up, the sum is going to be equal to 1800. Well, the sum of the interior is n minus 2 times 180. Two ways of going about doing this. The easy way is to just divide both sides by 180 right off the bat. And what is that? You're done. Or if you did it the other way, you multiply it out by a 180. You get 180 n minus 360. It works the same way. You know, honestly, there's nothing wrong with that, because in the grand scheme of things, if you're trying to work with these, you're going to start to see the same ones over and over again. You're going to know that a 12 side is going to be 1800. You'll know that an octagon is, I forgot it. But you'll learn the setups on those. They're not going to be that bad. Okay. What else do you want to look at on that? 20. 20? Exterior angle. That means that all of these have to add up to equal how much? 360. All of those have to add up to equal 360. So x, guys, x plus 2x plus 4x is subtract out the 150. There you go. Usually a lot of times when you're working the exterior angles, most people forget to add one of the angles. That's why you probably get something weird. Happens all the time. Sure. Count the angles. How many of them are there? 7, okay? Again, what's happening here in this one is you count the angles. You're always going to have the same number of angles as you will sides. Well, there's 7 of them. So to find the sum of the interior with 7, it's 7 minus 2 times 180. I believe you get 900. Has to equal all these added up. Well, x plus x is 2x. 2x and 2x gives me 6x. 20, well, let's do it this way. 300, 440, 460, 480. Two-step equation then. Really easy. Subtract 480, what is that, 320? 420? So you get 70 for x. And then I think it asks you to find the angles, which is substitute for x. Okay? Make sure your names are on it, send it on up, please. We'll start building into 8.2. What's wrong?
For 34, can you find the exterior angles?
Oh, you're overthinking it.
Yeah.
If each exterior angle is 3. Whatever. If each exterior angle is 3, and you know that the sum of all of them is 360, 360 divided by the number of sides is 3. What do you do with that? Remember all you do is flip flop it. It has 120 sides. Okay? So let's finish out into 8.2. And I know it's in here somewhere. Parallelograms. This is stuff you guys have all done. This is not difficult whatsoever. Parallelograms. When you're working with parallelograms, we're going to start looking at kind of like our quadrilateral family tree, if you will. And over the course of the next few days and whatnot, we're going to start looking more into the more specific four-sided figures. We'll look at rectangles and squares and rhombuses and kites and all that kind of fun stuff as we build them all through. But each and every single one of the following parallelograms, they're always going to have the same properties. You probably remember some of them from some point in time in your life. What is one thing you know, besides erasers stick to your nose, about a parallelogram? It has four sides. Oh man, you are so smart.
Wow.
I know. It has lines that are parallel. Yep. We're going to say that opposite sides are parallel. Remember how we just drew with the little triangles to show that it's parallel? So we know that opposite sides are parallel in a parallelogram. Gee, where do you think they got the name parallelogram from? All right. So if opposite sides are parallel, what else about the sides can you tell? You might remember. Who said it? You did. I didn't say anything. Opposite sides are also congruent. Something about angles. What do you think? Which one? Which angles? Opposite. Good. Opposite angles are congruent. Opposite angles are congruent. Now, I'm going to put a different picture in here real quick, and I'm going to see if you can figure something else out. I'll come right back to this. Two parallel lines are cut by a transversal. We know that happened, right? What did we say about the interior angles? Consecutive interior angles. Remember that? They add up to 180. We call them supplementary, right? Now, aren't these two parallel lines cut by a transversal? What can you tell me about consecutive interior angles? The supplementary. Every set of these angles, when they're what I mean by consecutive means in a row. This angle to this angle have to add up to equal 180. This angle to this angle have to add up to equal. This angle, and this angle have to add up to equal. So what we say is consecutive interior. Angles. This is really annoying if this doesn't work. Are supplementary. I don't know why. I've heard you guys have told me that other teachers have that problem too, right? I really got to figure out what's going on. It's not the it's something in the cameras. It's not registering it. I don't know why. It's dusty or dirty or whatever. So what we have here are opposite sides are congruent, opposite sides are parallel. Consecutive interior angles are supplementary. And there's one other thing that we look at when we're dealing with parallelograms. We look at their diagonals. Diagonal, just going from corner to corner. And what happens within these diagonals is that the diagonals bisect each other. The diagonals always bisect each other in a parallelogram. Okay? Yeah, if you didn't draw this picture big enough in the notes, it probably looks awful. Which is fine, not a big deal. So, again, what we have is opposite sides parallel, opposite sides congruent, opposite angles congruent. Consecutive interior angles are supplementary, and then lastly with the diagonals they bisect each other. Like I said, it's not that difficult. Which means we get to do stuff like this. Oh, we used to know that. Oops, wrong one. Sorry, I forgot this wasn't linked correctly. We can do stuff like this. Not working at all. So in this case here, this is a parallelogram, and I want to solve for the variables. I want to solve for k. How do I solve for k? That was awesome. It's good. Just set them equal to each other because they're sides. Variables on both sides of the equation, what do you do? Take on the little guy, subtract 5, add 9, so we get 8. Oh no! What times 8 is 16? 4. Boy, that was very hard to do. So I get 2. Obviously, the algebra here should be really simple. Shouldn't be very scary to work with. To solve for the angles, then, what do? Do we set them equal to each other, or they have to add up to 180? They have to add up to 180. So we can do this all in one step, right? What's 12 plus 5?
17.
And then negative 17 plus negative 41 is going to be negative 58. That has to equal 180. I just didn't feel like writing a J. So, two-step equation. Move your stuff around. 238, I believe. Yeah. Divided by 17, you get what? 1, 8, look at this. 14. There you go. And since the algebra here is not that difficult to work with, could you take 2 seconds and substitute back in to check your answers if you wanted to see if you got them right? Maybe. I might be putting you out. I apologize. It's too much work. The headband pulls your brain. Shut up. Oops, this one kind of cut itself out a little bit. Anyways.
I remember.
Let's take a look at this one. Again, we're working with angles. There's 2 different sets of consecutive interior, and there's one set that are opposite each other. But can I solve for the ones that are opposite each other? How? Can't. Two different variables. 2 different variables can make a big mess. No. Look at the.
Wait.
Yeah.
What you said? 980. Minus 4 to 180.
I can't write. What's happening here? What I want you guys to see is that you've got.
You said it already. Oh.
Yeah. you can't go and solve for both variables at the same time. You have to figure out what you can solve for first. In this case, you have to solve for G first. G, our consecutive interior, those two angles have to add up to equal how much? 180. So you just write it out. So you get 9G. Negative 14 and 5 is 9. Nine goes into 18 how many times? 9 goes into 9 how many times? Now to go to find H, you can do one of two things. No matter what, you're just going to substitute in for 21 for G.
Is that equal to 9H equal minus 4 equals 21?
No, because this is the G value. You'd have to take it and set it into here. So what's 21 times 3? 63. What's 63 and 5?
68.
So this angle here has to equal 68, which means that has to equal 68. What we're doing here is you can go that route, or if you want to do substitute into this G and make them supplementary, that works the same. Yes, sir?
You just said 9H minus 4 equals 60.
Yep, exactly what we're doing. Nine times what is 72? 81? Nope. 72. It's B. Okay? Like I said, not scary. It's normal math, right?
Now, I want you to throw us that curveball that you always throw us around this time.
Dwayne, you know me so well.
You make us feel very comfortable and you just kind of throw us a problem.
No.
Oh.
But it's not that I don't want you to do poorly at it. But in this example, I want to solve for all of the missing angles. It is legal. This is a parallelogram, okay? It is a parallelogram, because I think I cut off the instructions, but we'll just say it's a parallelogram. You have 1, 2, 3, 4, 5, 6, 7, 8 angles to solve for. Draw this a little bit larger, and we're going to use a whole bunch of stuff that you probably forgot about to set it up. So take a second and solve this, and or draw this out, and I want to walk you through a couple little tricks. All right, as you probably already noticed, there's a whole bunch of triangles here, aren't there? This is a vertical angle, so that's 60, isn't it? That's how you do these. And what you were doing is right, too. Good job, man. What's the supplement to 60? Which means that's 120. 60 and 85, subtract it from 180, it leaves you 120 and 45 leaves you. What Alonzo was doing was saying, hey, this is two parallel lines and this is my transversal. Well, that means this is 15 because they're alternate interior. That's 35 because they're alternate interior. 45 is 45 up here. 85 is down here. Now, the other thing I want to show you real quick. Remember what diagonals do to each other inside a parallelogram? What do the diagonals do to each other? They bisect each other. So if I know that these two are the same and these two are the same, aren't opposite sides also congruent? Don't I have a whole bunch of sides? So you have congruent triangles within this. That's why all this works. JC, you're looking perplexed. I try. Every once in a while, I try to sound like I kind of know what I'm talking about. She looks a little confuzzled. That's, and Dwayne, you were looking for the worst case scenario stuff. That's about as bad as this gets. Okay. I'm not lying. No. A lot of this stuff, it's not meant to be just horribly scary bad. There's a lot of little nuances that you're going to pick up on. And eventually, I mean, as we get into this more and more, we might take a sign value here or there if we're trying to find one of the missing side links or something. But we'll get to that when we get to it. For right now, we're just starting this stuff out. I'm not trying to twist it up yet. All right.
Oh, you did all that. Yeah.
Well, yeah, I mean, don't worry about proof, we're not gonna do any of that. We're not gonna do proofs, don't worry. I should make you do proofs. No, I don't wanna do these. Let me give you guys some homework. I don't have we didn't have that much of this stuff today, and it works out well.
I mean,
Let's bring all this to
Here's what I want to do. I want to start on this one. All right? Go ahead and get started on that now. To be honest with you, first hour I got done with a lot of this stuff about the same amount of time. And they were just about finished before they walked out the door. So there's no reason for you not to get this done in about 10 minutes. All right?
There's actually be a bunch of paperwork and then once it's OSHA and OSHA, there's